Hi guys, so the 2024 Physics Regents just released, so today we'll be going over parts A and B, which are multiple choice questions 1 through 50. So number 1, which quantity is a vector? So this is one of the most common first questions where they ask you to identify the vector or scalar quantity. Just remember that a vector has direction, whereas scalar doesn't. This is easy if you remember that for the first one, which is the answer, electric field is a vector quantity because it has arrows pointing in certain ways. For example, an electric field with a negative charge is going to be pointing towards it. The arrow is going towards the center. That's a direction. And a positive charge has arrows going outwards. This shows direction. Whereas choices 2, 3, and 4 don't show any type of direction. They're just types of units. Number 2. What is the magnitude of the eastward component of the velocity of an airplane flying at 612 kilometers per hour in a direction 40 degrees north of east? So let's draw this one out. This circle here is just going to be the airplane. It's going 612 kilometers north of east. So north of east means we start at east. So there's our east. And it's 40 degrees. So 612 kilometers per hour, and this is 40 degrees. So, in order to do this question, we need to find the east component. And to find the east component, we just use cosine, because adjacent over height. So, cos 40 equals adjacent over hypotenuse, which is x over 612. And once we do this work, we're going to get an x, or an eastward magnitude of 469 kilometers per hour. A car initially traveling at 25 meters per second is uniformly brought to rest as the brakes are applied over a distance of 40 meters. The magnitude of the average acceleration of the car while braking is... So, in order to do this question, first we need to write out all the information that we know. So we know that it starts at an initial speed of 25 meters per second. It ends by going to rest, and that means it's going to end at 0 meters per second. The distance that it travels is 40 meters, and we need to figure out the acceleration. So we could just use one of our kinematics equation, which has all of these components, and that equation is going to be Vf squared equals Vi squared plus 2AD. And when we plug this in, we're just going to get 0 squared equals 25 squared plus 2 times acceleration times 40. And once we do this math and we solve for acceleration, we're going to get 7.8 meters per second squared. Number 4, a brick starts from rest and falls freely from the top of a building to the ground. As the brick falls, its acceleration is 3. It's constant and its speed increases. So this is an easy concept question because you just have to remember that acceleration due to gravity is always constant. And if the acceleration is constant, then velocity has to be continuously increasing. Remember the relationship between those. For a graph, if it's velocity over time, if it's constant like this, then the acceleration over time graph has to be like that. Number 5, which object has the greatest inertia? So this is going to be number 4, a 2,000 kilogram truck traveling at 20 meters per second, because inertia is just mass, and 2,000 kilograms is the largest mass of all these choices. Don't pay attention to any of these. The velocity doesn't matter. Inertia is just mass. Number 6, an unbalanced force is always necessary to change the speed of a body. So it's going to be number 3 because none of the other choices are right. 1 and 2 are talking about being at constant velocity or being at rest, which means that the F net is 0. When your F net is at 0, you're a balanced force. And we're looking for the unbalanced force. And number 4 doesn't mean anything because you can change the position of the body while being at constant velocity. That just means that you're moving. But in order to change the speed of a body, you need to be slowing down or increasing, meaning that the forces are unbalanced. Number 7. Space probes launched from Earth send information back to Earth from space in the form of... Number 4. Electromagnetic waves. So this is just a common sense question, so this is just something you have to learn. Number 8. A ball is thrown from level ground at an angle of 55 degrees above the horizontal and lands on level ground. Neglecting friction, if the ball is thrown again at the same angle but with a larger initial speed, the ball will travel 3, both higher and farther horizontally. So, this question is also just common sense because if you're throwing something with much more initial velocity, it's going to go both higher and further. If you throw a ball with all your power, it's going to go further than if you only put a little bit of power in. See how that works? Number 9. A photon collides with an electron as represented in the diagram below. After the collision, the electron recoils and the photon is scattered in another direction with a longer wavelength than the incident photon. The increase in photon wavelength results because during the collision, the photon loses energy to the electron. So, when the photon hits the electron, the wavelength increases. If we use the equation E photon equals hc over lambda, or wavelength, we could see that it has an inverse relationship. When the wavelength increases, that means E photon has to decrease, meaning that if the wavelength increases, the energy has to decrease, showing that it's number 1. Number 10. What is the weight of a 60-kilogram student on the surface of Earth? So, to find weight, you just multiply mass and gravity, so you're going to do 60 kilograms times 9.81 meters per second squared, and you're going to get 589 newtons. Number 11. A 120 newton box is pulled by 48 newton horizontal force across a horizontal surface at constant velocity. The coefficient of kinetic friction between the box and the horizontal surface is... So, to figure this out, we need to use the equation force of friction equals mu Fn, or normal force. So we have all the components here, we just plug it in. So when it's saying that it's being pulled by 48 newton horizontal force at constant velocity, that means that our forces are balanced. So our force of friction is also just 48 newtons. We're trying to find mu, and our Fn is just 120. That's the normal force. So once we solve this out, we're going to get a mu of 0.4. Number 12. Box A has a mass of 10 kilograms and is at rest on a shelf that is 1.5 meters above the floor. Box B has a mass of 20 kilograms and is at rest on a shelf that is 3 meters above the floor. Compared to Box A, Box B has a gravitational potential energy relative to the floor that is 4 times as great. So for this question, we just need to use the PE formula and find both energies to compare. So our PE formula, or potential energy, is going to be potential energy equals mass times gravity times height. So for our first box, box A, PE equals 10 kilograms times 9.81 times 1.5. And for that, we're going to get 147. So for box B, we're going to do PE equals 20 kilograms times 9.81 times 3, which is 588. And if you divide 588 divided by 147, you're going to get 4, which means it's 4 times as great. 13. A 0.1 kilogram yo-yo is whirled at the end of a length of string in a horizontal circular path of radius 0.8 meter at a speed of 6 meters per second. The magnitude of the centripetal acceleration of the yo-yo is... So, for this question, we just use the equation for centripetal acceleration. So that is AC equals V squared over R. And we have all these components, so we just have to plug in. So AC equals 6 squared over 0.8. And once we do this math, we're going to get 45 meters per second squared. 14. A 4 kilogram mass is initially at rest on a horizontal frictionless surface. A constant 2 Newton force to the east is applied to the mass for a 5-second interval. As a result of this action, the mass acquires a... So, right off the bat, it says that the 2 Newton force is to the east. So we automatically know that 2 and 4 are wrong because those are to the west. So 2 and 4 are out. Now, to figure out the rest of the problem, we either need to find velocity or momentum with the components of mass, force, and time. If we look on the reference table, we can find the equation change of momentum equals F net times T. And we have all these components, so let's look. Change of momentum equals F net, 2 newtons, times 5 seconds. And we're going to get a change of momentum that's 10. And we have that answer choice right here. So that's how we know it's number 3. 15. A motor lifts a 1.2 times 10 to the 4th Newton elevator 9 meters in 15 seconds. The minimum power output of the motor is... So for this question, we're just going to use the power equation, which is power equals force times displacement over time. And we just plug that in. So power equals 1.2 times 10 to the 4th times 9 over 15. And once we do that, we're going to get an answer of 7.2 times 10 to the 3rd. 16. A train blows its horn, which emits a uniform sound as the train approaches a stationary observer. The observer hears a sound that has a... Let's see. So this question is a concept based on frequency, amplitude, and wavelengths. So when the train blows its horn, the horn has a consistent loudness. But when it's far away, it'll sound quiet. And when it gets closer, it's going to sound louder. So in this question, when the train approaches this observer, it'll sound louder due to the increased frequency and amplitude, which means it's going to be 4. 17. A wood block is pulled at constant velocity across a horizontal wood floor. Which type of energy increases in this block floor system as the block moves? So let's look at these options. We know it can't be 1 or 2 because the block is moving at constant velocity and it's at a constant height. So there's no change in potential or kinetic energy because potential and kinetic energy require height and velocity in their equations. If there's no change in those two components, then there's no change in the actual value. And we also know that it's not mechanical energy because mechanical energy is just a combination of potential energy and kinetic energy. So the answer has to be thermal energy because as an object is being constantly moved, the thermal energy will increase like how something will get hotter the more it moves around. 18. A total energy of 5 joules is used to move an electron from position A to position B in a uniform electric field. What is the potential difference between positions A and B? So first we need to look at the information the question gave us. We know that this 5 joules represents work. And we already have the charge because the charge is just the charge of an electron. And we need to find the potential difference, which is just voltage. So we could use the equation voltage equals work over charge. And we just plug in. So V equals 5 joules over 1.6 times 10 to the negative 19th coulomb. And this is because if you look on the reference table, the charge of an electron is just 1.6 times 10 to the negative 19th. And once we do this work, we're going to get an answer of 3.1 times 10 to the 19th volts. 19. A 0.14 kilogram lacrosse ball traveling west at 17 meters per second is brought to rest with a 0.21 kilogram lacrosse stick. if the force applied by the lacrosse stick on the ball is 220 newtons east, the force applied by the ball on the stick is 220 newtons west. So let me explain this question. This is just an easy concept because remember Newton's third law. Every action always has an equal and opposite reaction. So the force applied by the ball on the stick is equal to the 220 newtons the stick applied on the ball. And since the reaction is opposite, it should be 220 newtons west, which is opposite to east. Number 20. 4 wires are tested for electrical conductivity. All the wires have the same length and the same cross-sectional area, but are made of different metals. Which wire has the highest conductivity at 20 degrees Celsius? So, this question is kind of like a trick problem with the way they word it. We're looking for the highest conductivity, not resistivity. So we need to look on the chart on the reference table to see which one of these choices has the lowest resistivity, because conductivity and resistivity are opposites. If we look through the choices, we can see that silver has the lowest resistivity, which means it has the highest conductivity. 21. The angle of incidence for a ray of light striking a plane mirror is 20 degrees. What is the angle between the incident ray and the reflected ray? So, if we draw this out, let's just do, this is our incident, and this is our reflected. And here's our normal line. It's saying here that the angle of incidence is 20 degrees, so 20 degrees, and our reflected angle has the same angle as our incident angle. So this is also 20 degrees. So we can see that between the incident right here and the reflected ray over here, we have just the incident and reflected angles. So to find the full angle between the rays, we just add the incident and reflected, which is just 20 plus 20, and you're going to get 40 degrees. 22. As shown in the diagram below, mass m slides across a level frictionless surface with speed vi. The mass strikes a spring at position A, causing the spring to compress. When the mass is at position B, it is moving at a slower speed, Vf. Which statement best describes the energy conversion as the mass moves from position A to position B? So, first, we're comparing kinetic energy to elastic potential energy. So we should write out those two equations. So Ke equals 1/2 mv squared. And potential elastic potential energy is 1/2 kx squared. So first we can see that Ke is dependent on speed, the velocity component. And at position B, the box is moving at a slower speed. So that means that the kinetic energy should be decreasing. But elastic potential energy is based off of the change in spring length, which is x. And it says here that the spring compresses, meaning that there's a larger change in spring length. So that means that our elastic potential energy increases, giving us choice 1. Sum of mass m's kinetic energy is converted to elastic potential energy. 23. The diagram below shows a magnetic compass placed between unlike magnetic poles. The north pole of the compass needle will point towards C. So the reason it's C is because the north pole of the compass is going to point towards the south pole. So it's going to look like this. That's because opposites attract. 24. Which circuit diagram contains a lamp that will not have current passing through it until switch S is closed? This question is simple. As we can see, number 1 is an extremely simple circuit with just one battery, one light, and one switch. If you open the switch of a simple circuit, it won't work, and if you close it, then it will work. All the other switches are placed incorrectly, so that's how we know number 1 is correct. 25. The diagram below represents an electric circuit. The equivalent resistance of the circuit is, So to solve this, we just have to use the equation 1 over Req equals 1 over R1 plus 1 over R2 plus 1 over R3. Because this is a parallel circuit and this is the equation for finding the total resistance for a parallel circuit. So 1 over 3 plus 1 over 6 plus 1 over 9, because that's all these resistors. And after we do that, we're going to get 5.5 and 5.5 over 9, which is 0.61. So 1 over 0.61 is going to give us our final answer of 1.6 ohms. And that is answer choice 1. 26. An object is thrown vertically upward with an initial velocity of 9.1 meters per second. What is the maximum height reached by the object? So first, let's write down all the information that we do have. We have an initial velocity, or VI, of 9.81. We have a final velocity of 0 because it will stop once it reaches maximum height, and a gravitational acceleration of negative 9.81. And we need to find distance. So we're just going to use the equation VF squared equals VI squared plus 2AD. And we're just going to plug in. So 0 squared equals 9.81 squared plus 2 times negative 9.81 times D. And after we do all this math and solve for D, we're going to get a distance of 4.91 meters. 27. Which type of photon has the least amount of energy? So, in order to find which photon has the least amount of energy, we need to look at the different photon equations. In this case, we can use E photon equals HF. Because we need to look at frequency, since the answer choices are different energies on the electromagnetic spectrum. Since H is a constant, the only factor that makes E photon different is frequency. So the answer choice with the smallest frequency will have the smallest energy. And once we look at the reference table, we know that the smallest frequency here is radio waves. 28. A 7.5 kilogram object moving at 20 meters per second strikes a 60 kilogram object initially at rest on a horizontal frictionless surface. The two objects stick together and move off at a speed of... So, it's giving us two objects colliding and sticking together, which is obviously momentum. So the biggest rule for momentum is that it stays the same before and after collision. So first, let's calculate the momentum in the system before the collision. So our equation for momentum is P equals mv. So first, I'm going to calculate the momentum of the 7.5 kilogram objects. So 7.5 kg times 20 meters per second, you're going to get a momentum of 150. And the other object is 60 times 0, which just means the momentum was 0. So the combined momentum of this system before the collision was 150. So the momentum after the collision has to also be 150. So after the collision, the objects stick together, meaning the masses combine. So in order to calculate the speed of the objects once they combine, we just rewrite our P equation with the new mass of 67.5. So P equals mv. We know that the P, the 150, stays the same. So 150 equals 67.5 because these two masses combine times v. And once we solve that, we're going to get a velocity of 2.2 meters per second. 29. How is the electrostatic force between two positive charges affected as the charges are brought closer together? So this question is easy because you just have to remember that same charges repel. So it will be 2. The force of repulsion between them increases since it's two positive charges. They have the same charge. 30. What is one difference between magnetic forces and gravitational forces? So you have to remember what a gravitational force is. It's the force that pulls objects with mass together, meaning that it's always attractive. Like, would the earth ever repel you off the ground? No, because it's always attracting you towards the center of the earth. On the other end, magnetic forces can be attractive or repulsive because opposite charges attract while same charges repel. So that's going to be answer choice 3. Magnetic forces can be attractive or repulsive, but gravitational forces are always attractive. 31. A sound wave passes through an opening in a brick wall as represented in the diagram below. An observer standing behind the wall is able to hear the sound. This spreading out of the sound wave as it passes through the opening is an example of diffraction. So, this is just something that you're going to have to remember. The spreading of sound waves after it goes through an obstacle is diffraction. 32. A sound wave is emitted by a vibrating tuning fork. What is transferred as a sound wave travels to a student's ear? So, any type of wave is just going to transfer energy. There's no mass in a wave, so it's impossible for it to transfer mass. So the answer to this is going to be 2. 33. An electric current passing through a copper wire at constant temperature would result in 4. The production of a magnetic field around the wire. So, this is because you need to remember that when electric current full of moving electric charges passes through a wire, a magnetic field will be created. 34. The velocity of an object in uniform circular motion has a 1. Constant magnitude and changing direction. So, in this question, we know that they're talking about centripetal force because it says right here that it's circular motion. So, if the centripetal force is uniform, that means the speed is constant. However, the velocity is not. This is because velocity is dependent on direction, and the direction of the object is constantly changing. For example, if this object right here is moving in centripetal motion, over here the direction is going this way, while over here it's going this way. Right? So you see the direction changing. So that means that the circular motion has a constant magnitude, the speed stays the same, but the direction constantly changes. 35. Tuning fork A starts to vibrate at 320 Hz when it is held near tuning fork B, already vibrating at 320 Hz. Which phenomenon is exemplified by the action of tuning fork A? So, the answer to this is resonance. And let me tell you why. When you see a question talking about vibrations, you can automatically assume that resonance is the answer, because resonance is when one vibrating object causes the other to match its frequency, which is what's happening in this problem. Tuning fork A starts to match the vibrations of tuning fork B, which is resonance. So now we're on to part B. So, 36. A light ray with a frequency of 5.09 times 10 to the 14th Hertz has a wavelength of 2.44 times 10 to the negative 7th meter in diamond. The wavelength of this light ray in sodium chloride is... So, the first step in this question is finding the velocity of the light ray in sodium chloride. We can use the equation N equals C over V in order to do this. So we just have to look in the reference table to see what the N, or the index of refraction for sodium chloride is, and that is 1.54, and we just plug in the rest. So 1.54 equals C, which is 3 times 10 to the 8th, that's the speed of light, over V. And once we do that, we're going to get a velocity of 1.9 times 10 to the 8th meters per second. And we already have velocity and the pre-established frequency, so we could just plug that into the equation V equals F lambda. So 1.9 times 10 to the 8th equals 5.09 times 10 to the 14th times lambda. And once you do that, you're going to get a value for lambda, or wavelength, of 3.83 times 10 to the negative 7th meter. 37. The diagram below shows resistors R1, R2, and R3 connected to a 12-volt source. The current flowing through resistor R3 is... So, This circuit gives us the total voltage right here, along with 3 different resistors. So, in a series circuit, remember that the current is constant. However, in order to find the current, we can't just use resistor 3. We need to find the total resistance because it only gave us the total voltage. So, to find the total resistance, we use the equation Req equals R1 plus R2 plus R3. So 15 ohms plus 21 ohms plus 24 ohms equals 60 ohms. So that's our total resistance. Now we can use the equation R equals V over I. So 60 ohms over 12 volts equals 12 volts over current. And once you do that math, you're going to get a current of 0.2 amps. 38. A charge of 25 coulombs moves past a point in a circuit in 2.5 seconds. What is the current at that point in the circuit? So, the question gives us charge, time, and we need to find current. The equation with all these components is I equals change in Q over T. So we just have to plug that in. So I equals 25 coulombs over 2.5 seconds. And we're going to get a current of 10 amps. 39. Which statement describes an object with constant kinetic energy? So choice 3 is clearly the answer because, remember, the equation for Ke is 1/2 times mass velocity squared. And if you want a constant kinetic energy, you need to keep the components of mass and velocity constant. Choice 3 states that it's going at constant speed, while the others are all speeding up or slowing down. So that's how we know that choice 3 is correct. 40. Which phrase describes a box in equilibrium? So, this is another easy question, as equilibrium is when the net force on an object is 0. If the object is at rest, that means the forces are at 0 and it's balanced at equilibrium. So that's how we know that it's choice 2, because it says the box is at rest. 41. Quarks may combine to produce a meson of charge. For this question, we have to look at the reference table with the matter chart. We can see that a meson is composed of a quark and an antiquark. So, those things just cancel out because an antiquark has the same value as a quark, just negated. Meaning that, for example, if the quark is 1, then the antiquark is -1. So it just cancels out and turns into 0. That means that the quark may produce a meson of charge 0e, because a quark and an antiquark always just cancel out. 42. The diagram below shows waves A and B as they travel through a region in the same medium. Which wave best represents the superposition of waves A and B? So, the superposition of a wave is basically just the two waves added together. So, since the positions of A and B are basically flipped or 180 of each other, the result is going to be a smaller wave because they subtract from each other. We just have to figure out which one of these options looks most like the result of this. Yeah, A is bigger than B here. So it should end up looking like something like this. And you just continue like that. So we're looking for a pattern that looks like that. And that is choice 3. 43. The diagram below shows the direction of wave travel and the direction of medium particle vibration for different waves. Which diagram best represents the characteristics of a sound wave? So, one of the things that you're going to have to memorize is that sound waves are longitudinal waves. Remember that. Sound waves are longitudinal. And longitudinal waves go from left to right or back and forth. They do not move up and down. Waves that move up and down are transverse waves. So longitudinal waves go right to left or back and forth. So if we look at these choices, that is going to be 1 because this is going left to right or back and forth. See? 44. In a sample of gas, many excited hydrogen atoms are in the n equals 4 energy level. What is the maximum number of different photon energies that can be emitted by these atoms as they return to the ground state? So, this question is a little bit tricky because you have to count all the ways you can get from n equals 4 to a lower state. You might think it means n equals 4 to the ground state, but it says as they return to the ground state. So it can be any lower level. So from n equals 4, there are 3 different ways to get to a lower level. So I'm going to write this out to make it a little bit easier. So from n equals 4, you can go to n equals 3, n equals 2, or n equals 1. Now from n equals 3, you can go to n equals 2 or n equals 1. From n equals 2, you can only go to n equals 1. So this is 1, let me do a different color. 1, 2, 3, 4, 5, 6 different ways. So it's choice 1. Do you guys see how it's just finding the different ways you can get to a lower energy state? Base your answers to questions 45 and 46 on the information below. 2 students did an experiment to measure the acceleration of a freely falling object. One student dropped an object from rest. The other student measured the distance fallen by the object and the corresponding time of the fall. The data for the dropped object are shown below. Distance fallen by object equals 2.4 meters. Time of fall equals 0.71 seconds. 45. Based on the data for the dropped object, the experimental value calculated for the object's acceleration is... So, for this question, we just have to use one of our kinematics equations. We have distance, time, and initial velocity since it says that the object starts at rest. So we can use the equation d equals vit plus 1/2 at squared. And we just plug everything. 2.4 meters equals 0 because the initial vi equals 0 times time, that doesn't matter. 1/2 times acceleration times 0.71 squared. So you're going to get an acceleration of 9.5 meters per second squared. And that is choice 2. 46. The ideal value for the acceleration differs from the one obtained experimentally by the students. What is one possible cause of this discrepancy? So, the experimental value and the ideal value are slightly off, and if you've ever done a physics lab experiment, you should know that's mainly due to human error. So the choice here is going to be 4. 47. Which graph represents the motion of an object falling freely from rest near the surface of the moon? So, the answer here is choice 3. Because remember, these are distance over time graphs. The gravitational force on the moon is much less than on Earth, but it still exists, meaning that there is a constant acceleration. Graph 3 is the correct choice because the distance is increasing exponentially, meaning that the velocity is increasing at a constant pace, and the acceleration stays the same. It's going to look something like this. Since distance is exponential, velocity will go like this, and acceleration will just go like this. 48. The diagrams below represent the initial velocities VI of 4 identical projectiles launched from level ground at various angles above the horizontal. Which projectile will have the longest time of flight? So, the answer is going to be choice 4, because the bigger the initial angle of a projectile is, the longer the maximum height will be, which leads to a longer time of flight. 49. 4 forces act on a crate on level floor, as shown in the diagram below. At the instance shown, the crate is... So, we know it's not going to be 3, or 4 because these require a net force of 0. This crate has unbalanced forces. See, the frictional force is 50, but the force of the rope is 100. So that's unbalanced. Since F rope outweighs FF, the box will have a force of 50 newtons acting to the right. So that means it's accelerating to the right. So the answer choice is 1. 50. The graph below represents the relationship between the potential energy stored in a spring, PES, and the elongation of the spring, X. The value of the spring constant is... So, this is a simple question. It's giving us all the components that we need. Let's use this point for our calculations. Here, there's a potential energy of 0.05 joules and a spring length of 0.02 meters. So now we just plug it into the equation. PS equals 1/2 kx squared. So PS, or 0.05, equals 1/2 k 0.02 meters squared. And once we do that math, we're going to get a spring constant of 250 newtons per meter. So, that is our last question for today. Our next physics video will be reviewing the short response portion of the 2024 Regents. Have a great day, and thank you guys so much for watching.